Hello, Math 140. Welcome back. We are covering 5.3, which deals with linear programming. So this is where all the magic happens that you learned in 5.1 and 5.2. So sit back, put on your thinking caps, and take notes. Okay, so 5.3. Can you see that? Okay. Linear programming. This one might take a little bit longer. All right, so what is linear programming? So it is the use of linear systems of inequalities to help in decision-making process. I know I should have said the. Okay. All right, so for example, suppose that you have a business and you're trying to figure out some production scheduling problems. Okay, so suppose that you are, suppose that you produce two types of tents. A standard tent and an expedition tent. Okay? And suppose that you want to know how many of each type should be produced per day to maximize total daily profits. Okay, so this kind of problem deals with linear programming. So what happens here is we're going to get some information. So this is the problem that I included in the link. So hopefully you have that on your screen or printed out so that I don't have to write the whole problem out. Okay, so to figure out if you're making two types of tents and it, it takes a certain amount of time to make this type of tent, a certain amount of time to make the other type, and a certain amount of time to assemble them, and then you can only have a certain amount of hours per day for both putting it together and also cutting all the materials. Okay. All right. So if you have the problem in front of you, we already know that for profits you get $50 for every standard tent. We're going to let this be X, and then you get I think it's $80. Yeah, it says $80 for profit for that other type of tent. Okay, so we're going to let X represent the number of standard tents, and Y is going to represent the number of expedition tents. And so your profit equation, P for profit, is going to be, we said you make $50 for every standard tent sold, and you make $80 for every expedition. Okay? So that's our profit equation, and we want to know, well, how many of each should I make so I maximize my profit? Okay? So if you take a look at the information here on that worksheet that I gave you. So the cutting department, and then we have the assembly department. Okay. I'm just going to organize the information here a little bit. So here we're going to put down our labor hours. Okay, so labor hours. Okay, and we're going to have this column over here. This one is for the standard tent, and this one's for the expedition tent. Okay, so the cutting department requires 1 hour to cut up all the materials for the standard tent. The expedition tent requires 2 hours to cut up all the materials. The assembly department, it requires 3 hours for the assembly department to put together the standard tent. And over here, it requires 4 hours to assemble the expedition tent. Okay? Now, if you're running a business, you don't get to make the workers work forever. There is maximum labor per day. Okay, and so here, the cutting department, 32 hours in a day. Here, 84 hours in a day. Okay, so what happens is over here with these restraints, we have our system of inequalities set up from here. And what we're trying to do, our objective is to figure out, okay, well, once we solve for this system that's made up of these equations or these inequalities over here, and then we have this profit equation, then what we're trying to do is, okay, of these solutions, which one of these solutions, these XY solutions, will give us the maximum profit here? Okay, so our system is going to look like this. Our system of inequalities. Okay, so X is the number of standard tents, and Y is going to represent the number of expedition tents. Okay, so our system is going to look like this. Okay, so right here we have this first inequality. So the labor hours, 1 hour for every standard tent, plus 2 hours for every expedition tent. But these hours cannot exceed 32 hours, so it has to be less than or equal to that. Over here in the assembly department, we have 3 hours for every standard tent, plus 4 hours for every expedition tent, but those total hours cannot exceed 84 hours. Okay, so we have this, and of course we have our standard. Okay, well, of course we're talking about hours and number of tents to be made, so of course X has to be greater than or equal to 0. We're not going to have negative tents, and Y has to be greater than or equal to 0, because again, we can't have negative number of tents. And again, this here, these two put together puts us in what quadrant?
The top greater than or equal to 0, the one on the top right.
Yes, the one in the top right, which puts us in quadrant 1. Okay. All right, so this here, these two automatically put us in quadrant 1, so we just have to graph these two over here. Okay, so that's what we're going to do next. So go ahead and let's do a 7th inning stretch while I erase all of this. Okay, so if you didn't quite copy all of this, go ahead and hit the pause button. If you did finish copying it, go ahead and stretch your legs while I get this cleaned up. And I'm going to write down this profit equation and our system again on this next one. And then we'll just work from there. Okay, so here we have P equals 50x. That's how much profit we make for every standard tent. And we make $80 for every expedition tent. Okay, so this here is called what we call our objective function. So the objective function is the one that's sort of the one that we are trying to focus on. We're trying to figure out how to maximize that that equation. So here we're trying to figure out how to maximize our profit. Sometimes you might want to minimize something. So so then your objective function, you're trying to figure out, okay, well, how can I make it the smallest possible? Okay. Right here we're trying to make as much profit as possible. Okay, so our system, we have, here I'm going to do this. This is our objective function, and then we have these restraints, x plus 2y less than or equal to 32, 3x plus 4y less than or equal to 84. These are from what we had from our chart for cutting and assembling. Okay. And then we have this here, x is greater than or equal to 0, y is greater than or equal to 0, which puts us in quadrant 1. Okay? All right, so if we do that, we know we are in quadrant 1 already. Okay? So we're in here based on these two. Okay? So let's go ahead and graph those two. If I do the first one, x plus 2y equals 32. And I do my table. When x is 0, y is 16. When y is 0, x is 32. Okay, so 0, 16. I'm just going to go ahead and make that 16 right over there. 32, 0. So this is right around 32. Okay, it's going to be a solid line. And again, I don't have to draw my line out here. And I don't have to draw my line beyond here because we already know that we're restricted to quadrant 1. So I'm just going to draw my line and stay within quadrant 1. Okay, 0, 0 is available. So I'm going to check 0, 0. So 0 plus 2 times 0 is less than or equal to 32. 0 is less than or equal to 32. Is that true or false?
True.
Okay, so that is true. So where should I shade if this is 0, 0? Above the line or below?
Above.
This is 0, 0, and it came out true.
Oh, below.
Below. Okay, so now I am in here. Okay, I'll just make it darker and darker as we go.
I just want the people to know that this is a very heavy camera, and we set up a stand so that I wouldn't have to hold it the entire time. And clearly I'm holding it, so if I don't know whether it's up or down, it's because my arms are about to fall off. And the lighting is going, so I have to get pretty close.
Okay, I will hurry.
Take your time.
Alright, so when x is 0, y is 21. When y is 0, x is 28. Just double check that. Okay, so 0, 21, somewhere just past 16. And 28, 0, something just short of 32. Okay, and solid line. But again, staying within the quadrant 1 because I know I don't need anything outside of quadrant 1. So there's my line. Okay, 0, 0 is available. So when I check 0, 0 into this inequality, 3 times 0 plus 4 times 0 is less than or equal to 84. So 0 is less than or equal to 84. True or false?
0 is, that is true.
Okay, so where Where should I shade?
Below.
Okay, below, but I don't need this piece right in here, this little sliver. I don't need that because I'm trying to look for where they're going to overlap. So they are going to start overlapping right in
there.
here. Okay, and all of this right here.
And you don't need that bottom one too.
Yeah, I don't need this bottom sliver either. Okay, because I have to stay below this line and below this line. Okay, so this here is my feasible region, and so this is where all of my corner points come into play. So what point is this one?
0, 0.
Good. And then this one is?
0, 16.
Good. And what is this
or
one?
actually, that's 16, 0.
No, it's 0, 16.
Oh, it is 0, 16.
Okay, what is this one?
28, 0.
Good. Do you know what this one is?
That one is probably...
Okay, so we don't have time, so
I'd say it's about 14, 12.
Okay, so all right, so we need to figure out this point, which is the point of intersection of these two lines. So then that is really the solution to this system here. So you can use whatever method you want to use to solve this system. I'm going to use elimination method. Okay, so I'm going to use elimination method. So we're going off to the side here, and we have to do a little bit of work now because my graph isn't as nice as the last one, so I can't really guess that one and plug in what I think it might be because this is pretty off. Okay, so I'm going to go ahead and I'm going to eliminate my y's. So I'm going to make this a -4 by multiplying this one by -2. Okay, so -2x minus 4y equals -64. And I'll bring this one down. Okay, so now my y's eliminate, and I get 3 minus 2x is 1x equals, and over here I get 20. Okay, so x equals 20. So far I know it's 20, and let me plug this in. I will use the first equation. 20 plus 2y equals 32. So 2y equals 12, so y equals 6. So this point is roughly 20 and 6, which looks like it is, right? That makes sense, just below 28 and below 16, okay? So this is the point 26. So these corner points right here, 0, 0, 0, 16, 26, and 28, 0. So what happens is when we're trying to figure out the maximum profit over here, it turns out that the solution for x and y, how many standard tents and how many expedition tents should you manufacture in a day to maximize your profit, it turns out those two numbers fall somewhere in this region here, this feasible region. So there are a bunch of points in here. So if we try testing every one and find out which one is our maximum profit, that's going to take forever too. Okay, so it turns out we can even narrow down our choices even some more. It turns out the x and the y that maximize this equation over here, that maximize our profits, turn out to be one of these corner points. So instead of testing every single point in the feasible region, we only need to test the corner points. Okay, so we're going to do that next to see which one we have. Okay, so hopefully you understand what I did here, because this point, these three are clear. This one is the point of intersection between two lines. Remember, that's when we first started learning about systems. The point of intersection between two lines, we know how to solve that. We learned how to solve that for that point by substitution method, elimination method, graphing method, and then all of those matrix methods. Okay? All right, so let's take a look, and what we're going to do is we're going to take all four of these points, we're going to plug them into this equation, and we're going to see which one yields the highest profits. Okay? All right, so let's start with 0, 0. Okay, So plugging in 0 for x, 0 for y. Let's see what we get for our profits. I think you can guess. What did we get for our profits? 0. Okay? All right. 0.16. P equals 50 times 0 plus 8 times 16. So we get 0 plus 1,280. So this is what we get here. Okay? And then we're going to test 26. Okay, so 26, we get 50 times 20 plus 8 times 6. Is that 80? That's supposed to be 80. Okay. I forgot the 0 there, but these numbers are still correct. Okay. Just put the 0. It's 80. All right, and so we get 1,000 plus 480. So here we get 1,480. And then we have one more to test, 28.0. 28.0, and we get 50 times 28 plus 80 times 0. So here we get 1,400 plus 0. So that's just 1,400. So we see here, of these 4 corner points, this one over here yields the largest profit. So this tells me that I need to, if I want to maximize my profits, then I need to make 20 standard tenths. And I need to make 6 expedition tenths. Okay? That's how many you need to make of each to maximize your profits. Okay? All right, so that is about it. So again, you only need to test all of the corner points. Okay? All right, so that's it. If you have any questions, you can email me, you can text me, you can post your question in the discussion section in Canvas. All right, have a good day.